The electricity board is setting up an electric tower between two villages. The ratio of the distance between the tower and the two villages is 2:1. If we plot the villages and the tower on the graph, can we find the exact location of the tower? In this lesson, you will learn about the section formula. At the end of this lesson, you will be able to derive the section formula, apply the section formula to find a point that divides a line segment in the given ratio, and identify the corollaries of the section formula. Given the two endpoints of a line segment, you can determine the coordinates of the point that divide the line segment in the given ratio using the section formula. Let AB be a line segment. The coordinates of the points A and B be x1, y1 and x2, y2 respectively. Let the point P x, y divide the line segment in the ratio m:n. Now, let's see how we can derive the formula to find the coordinates of point P. We need to find the x and y coordinates of point P using the values of m and n, and the coordinates of point A and B. First, we draw perpendiculars from points A, P, and B on the x-axis. The points where these perpendiculars intersect the x-axis are named Q, R, and S respectively. Then we draw AC perpendicular to PR and PD perpendicular to BS. Two triangles ACP and PDB are created. You will observe that angle ACP is equal to angle PDB, that is 90 degrees. Angle PAC is equal to angle BPD. Based on the angle-angle AA similarity criterion, we can conclude that triangle ACP is similar to triangle PDB. Since one of the angles is 90 degrees, they are similar right-angle triangles. In similar triangles, the ratio of the corresponding sides are equal. This leads us to equation 1. AP divided by PB is equal to AC divided by PD is equal to PC divided by BD. As you can see from the graph, AC equals QR. QR is equal to OR minus OQ is equal to X minus X1. Thus, AC is equal to QR is equal to OR minus OQ is equal to X minus X1. Similarly, PD is equal to RS. Thus, PD is equal to RS is equal to OS minus OR is equal to X2 minus X. Now let's move on to determine the heights of both the right-angle triangles. PC is equal to PR minus CR is equal to Y minus Y1. Similarly, BD is equal to BS minus DS is equal to Y2 minus Y. Earlier, from equation 1, we get AP divided by PB is equal to AC divided by PD. Substituting the values of AP, PB, AC, and PD in the ratio of the corresponding sides, you get m divided by n is equal to x minus x1 divided by x2 minus x. Rearranging the expression, you get x multiplied by m plus n is equal to mx2 plus nx1. Simplifying the expression, you get x is equal to mx2 plus nx1 divided by m plus n. Similarly, you can substitute the values for sides PC and BD. From equation 1, AP divided by PB is equal to PC divided by BD. Rearranging the expression, you get y multiplied by m plus n is equal to my2 plus ny1. On simplifying, you get y is equal to my2 plus ny1 divided by m plus n. Thus, the coordinates of point P can be calculated using the formula obtained. mx2 plus nx1 divided by m plus n and my2 plus ny1 divided by m plus n. This formula is called the section formula. According to the section formula, any point P, x, y dividing a line segment in the ratio m:n can be represented as mx2 plus nx1 divided by m plus n and my2 plus ny1 divided by m plus n. By applying the section formula obtained, you can now determine the exact location of the electric tower. Let's review the problem again. The village A is located at 2, -1 and village B at 5, 2. The distance of the tower from village A is twice the distance of the tower from village B. If the map of this region is transposed onto a graph, find the exact location of the tower. According to the problem, coordinates of village A, x1, y1 is equal to 2, -1. Coordinates of village B, x2, y2 is equal to 5, 2. The ratio of the distances of the tower from villages A and B, or m:n equals 2:1. Substituting the coordinates of A, B, and the ratio m:n in the section formula, you can determine the coordinates to specify the position of the tower. Simplifying, you get the coordinates of P as 4, 1. The electric tower is located between villages A and B at 4, 1. Some corollaries to the section formula can be derived for some specific cases. According to the first corollary, where the ratio of sections of a line segment m:n equals 1:1, the point is the midpoint of the line segment. In such a case, the midpoint of a line segment joining x1, y1 and x2, y2 is x1 plus x2 divided by 2, y1 plus y2 divided by 2. The second corollary relates to the coordinates of the centroid of a triangle. The centroid of a triangle is the point of intersection of its medians. The centroid of a triangle divides the medians in the ratio 2:1. Thus, based on the section formula, centroid G of a triangle with vertices x1, y1, x2, y2 and x3, y3 is x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by